Hello everyone, welcome to CAD Max Pro. This is Suraj. So in the previous session we have discussed about the point creation and line creation. Now in this session we will discuss about the plane creation. So I'm just importing the plane file. Okay. Now here I'm just selecting one of the plane. Here you can see different types of planes are available, like your offset from plane, parallel through point, normal to plane, through 3 points, through 2 lines, through point and lines, through planar curve, normal to curve, tangent to surface, equation, mean through point between. Okay, so one by one we will cover the different types of a plane. So first one is offset to plane. Okay, so if you have any plane, let I am selecting the XY plane. I want to hide this XY plane also, and I want the plane will create some offset value. Here you can define the value of the offset, let 20, and here you can give the direction of the, if you want to give it reverse direction, you will give it reverse direction according to your requirement. If you want to do repeated object, let preview and okay. So here I cannot repeat the offset plane again and again. So for that I have one of the option that is repeated after OK. So I'm just creating reverse direction, preview, after OK again it is coming repeated. So how many points you want, you can define here. Planes are you want, you can define here. So you can see directly it is creating in 8 planes are created in other geometrical set. I'm just deleting this one. We'll do it again, the same thing. I'm just going to create a plane, go to the repetition, my reference is this one, reverse direction, and preview. Okay, now here it is showing you can create in a new body or you can go with the same geometrical set. I'm just check of this one. You can see the point plane is created in the same geometrical set. If you check on that in a new geometrical set, then in your new geometrical set the plane will be created. Okay, let I will delete this. This is how we can create the or offset the plane, create the plane by using the offset option. And now second one is your parallel through point. So I want to create a point which is a parallel through point. So if you check this option, you can see that it is asking a reference and a point. My reference is here, means this xy plane, and with respect to this xy plane I want to create a plane in a particular point that should be parallel to the point. You can see this plane has been created with respect to xy plane and it is parallel, and the position of the plane is in your point 5. So in the here in this option you can create the point a plane by using the parallel through point. Then next one is normal to plane. So as you can see, you can define the rotation axis and reference and angle. So my rotation axis is this one. My reference, let xy plane. My reference, let this one. I'm just creating a plane which is normal or angle to plane, my let my reference is this plane, and rotation I want to rotation with an axis this point. Point here, angular normal to plane, give the rotation axis. This is my rotation axis, and angle I want 8, and this is my reference. Let my rotation axis is x-axis. Okay, in this x-axis, my rotation axis is x-axis. I want to rotate this plane with an angle. I want to create a plane which is the angle creating 8 degree or 20 degree, let. Okay, then preview. Okay, so here you can define normal to plane. You can directly click on normal to plane. Automatically the plane will create a normal to that reference plane, and project rotation axis on the reference plane. You can go with this. You can see the reference axis will project in the reference axis. Rotation axis will project in the plane. So say again similar, repeat object after OK. You can go with the repetition process with this repeat object after OK. Okay, the next types of a plane, it is your throw 3 point. So I have, you can see I have 3 point. I'm just selecting the first point, second point, and third point, and the plane will create within the first point. Okay, and by using this 3 point, the plane has been created, and which is parallel to that first point. Okay, the next one is through two lines. So I want to create a point between two lines. This is my first line and this is my second line, and the plane has been created here. This way we can create the plane. The next one is here point through point and line. So I want to create a point, create a plane through point and line. I'm just deleting one of the line here for clearly understanding. For just creating the point, here it is showing it, here it is acting in the pop-up window, that is you need a point and a line. So I am just selecting the point. I want to create the plane or this point, and here in this line, point through line. Just creating a point. Okay, I'm selecting this through point and line. I want to create the point through this line. You can see the line is created. You can change this point also here. Okay, the plane is created with respect to the point and as well as the line. By using the line and point we can create the plane. The next one is your through planar curve. So through planar curve, here it is showing the curve. So through planar curve, by default it will create the plane in the middle. Then the next one is your create the point which is normal to curve. So here it is axing a curve and normal to curve. And if you want to define any point, you can, by default it will come in the middle. If you want to define the point, you can go with the point, or you can go with the ratio. So as it is 0, it is the plane will create in the start point a 1.25, or you can go with 0.5, means it will create in the middle, and in the one it will create in the next extreme point. You can see by using this ratio option you can manipulate the plane position while creating the plane normal to the curve. You can go with the reverse direction also. Preview. Okay, now the next one is your tangent to surface. Okay, tangent to surface. So for that I need a surface. Let just creating one of the surface for your understanding. Yes, okay, just creating the space, and want to delete something. Okay, I want a plane which is parallel to the, or is tangent to the, to this surface. So I'm just creating the plane and selecting this appropriate type, that tangent to the surface. Click on the surface and click on the point of the surface, and you can see the plane is created which is tangent to the surface. You can see the plane is created which is tangent to the surface. The next one is your next type of plane is equation. So for that you can give some value. So plane type is equation. You can give some value of the point. I'm just selecting the point. Let this point. Okay, preview. The plane is created of this point, and it has some equation value. Normal to the compass, the plane will be created, or parallel to the screen. Parallel to the screen, the plane will be created. Parallel to the screen, the plane will be created. Later in here you can see the parallel to the screen you can create it. You can go with this same, go to the view toolbar, make it front view, and now I want to create the plane which is parallel to the screen. So automatic the plane will created which will be parallel to the screen. Then the next one is a mean throw point. So I'm just selecting some of the point for creating the point. So automatically it will create the plane by using the 4 points. So mean throw point. So it will calculate the distance of the 4 point, and divided by 4 it will create the point. Divided by 2 it will create the plane with that equations. Then the next one is your between two planes. So I'm just create for between two planes. I'm just creating one of the plane here. I want to create between these two plane. So you can go with this option and go for the last one, between two plane, first one, second one. In the middle I want. Here also you can find the ratio. You can change this one for reverse direction. Preview. Okay, in this way you can create the plane. Now the next one is your projections. So there are two type of, if you want to project some element or a wireframe element in a surface, for that you can go with this projection method. There are two types of projection. One is your along with direction, one is normal. So first discuss about the normal. Okay, I want to project this curve with the support of this. Okay, so in that one you will find the nearest solution. So smoothing, you can go with the non or tangency or curvature. Extrapolation mode, tangency or curvature, you can see. So first we will go with the normal one. You can see the change. Just see the change, what is happening with the different option. If I will check of this nearest solution, you can see it is going far to this, the length of the projected curve has changed. If I will go with the nearest solution, the nearest one it will show you. Okay, then you can go with the tangency mode, and you can give the deviation 0.001, or a curvature mode can give the maximum deviation of 0.001. Here 3D smoothing also you can provide. Okay, nearest solution, extrapolation, you can give curvature. So when you will give the curvature, it will extrapolate to the end. In tangency mode also it will extrapolate to the end. Extrapolate non means it will create the nearest solution only. Okay, so hope you got the concept of normal. Now we will project the same curve in the second method along with direction. Now I want to project the same element, and the support is this one. I want to project in Z direction. You can see, just projecting this, the projection is different. Okay, it is coming in Z direction, which is perpendicular to this surface. Okay, so here also you can go with the curvature. So curvature means it will the curvature continuity, and you can give with the curvature of extrapolation. So it will create end to the edge. The projected element will create an end to the edge, or you can give the direction of this, you can see. And here it is the far solution. If you go give with the nearest solution, the curvature will create in nearest solution. Make sure the curvature direction give properly while along with the direction. So the curvature direction should be perpendicular. Make sure that one to be perpendicular. Preview. Okay. Okay, along with the direction, the curve is projected on the surface. Then next one is intersection. Okay, so intersection is nothing but if you want to create a intersection line over this surface with respect to any plane, just hide this two plane. hide these two project curve. Now I want to create a intersection. Okay, so just create some offset plane. I want to create an intersection between this surface and this plane. Okay, so I'm just creating this intersection. I am the surface which we want to create an intersection line, and the second element is the cutting line element to cut. You can see the line is created intersection. Similarly, when you can go with the intersection with this surface and this plane, preview. Okay, so intersection line is created over this surface which is projected over the surface. You can not only you can perform the intersection between surface and any element. You can go with the wireframe. I want to create a intersection between this curve and this plane. Okay, so if I will create the intersection between this curve and plane, then the point will create it. Now here it is creating the surface. I am creating the intersection between the surface and plane. That's why the line is projected line is created over here. Now let's try with this. Go with this plane. Sorry, I'm creating the intersection between this curve and this plane, and with the direction of x-axis. Preview. The projection. Okay, I'm just creating the intersection. This is my first curve, and this is my second element which you want to intersect. Create. While intersecting, it is showing a intersection point, because while cutting the element or this curve with respect to this plane, it will intersect in a particular point as it is a curve. The next one is a parallel curve. Parallel curve. So you can see I want to create a parallel curve with this. Create a parallel curve of this with the support of this. Okay, I'm just creating the parallel curve. We can go with this, the point selection, this. Here we can find the parameters mode, equichildren, or parallel corner type, sharp. Then smoothing you can provide, curvature or tangency. I don't want to create the point here. I want both the side. Just click OK. If you want to go with the repeat object after OK, so you can go with this, extrapolate up to the support. You can see up to the support the parallel curve is created and extrapolated. Okay, hope you got the concept of this parallel curve. Now the next one is rolling offset. So I'm just hiding this element, hide this element. Okay, I want to you just see the functionality of this rolling with object. So here the support let xy plane. Okay, the support yz plane and offset I want 3 mm. So you can see it will create a rolling element. You can understand very clearly with this element. Just go with the rolling element, rolling offset definition, select the one and select the yz plane, and here you can see it will create a elongated hole. It will create a elongated hole over this surface and the offset value is 3 mm. In this way you can create a elongated hole or a rolling surface rolling element by using this rolling offset without going through the 2D workbench. Then next one is your 3D curve offset. I want to offset this 3D curve in the pulling direction, let Z direction. I want to offset this one. Let this pulling direction is XY. In X direction, I'm just pulling this one 1 mm. Okay, you can change to Z also. Pulling direction 1 mm. Okay, it's not coming because it is parallel to each other. Y. Okay, the pulling direction should be perpendicular to each other. So here as it is a place in YZ plane, so the pulling direction should be X. So here you can give the value of the pulling direction. You can see previously it was 5, it was 3, the dimension now it is coming 4 by using this pulling 3D curve. Here you can give the radius as per your requirement. Preview. Preview, reverse direction, preview. Okay, we got the concept of this offset, 3D offset. Then you can go with this circle. Just deleting this component, create a point as a coordinate x with some value. Then I want to create a circle. Here for that I need a center point and a support plane. Let it is xy plane. Okay, let make it yz plane. Yz plane, and I want my radius 10. Here you can see here it is showing the here by the icon which is starting 0 degree and end with 180 degree. You can change the value and if you want to create a complete circle you can change this value 180 to 360, or you can directly go with this whole circle. So automatically the circle will create as a closed circle. So here you can go with the geometry on support or a axis computation. So geometry of support is your nothing but your center point, or axis rotation is nothing but your axis where the circle is rotated. Okay, click OK. Okay, in this way you can create the circle. Then here it is corner. Okay, so for that I'm just creating one the spline. I'm just creating two spline. Okay, I'm creating two spline. Exit up. Again I want to create the spline. Exit tab. Then here I can go with this corner. First element, second element. Okay, so this is not the exact way. Here it is your connecting curve. Corner I will tell you. Here it is a connecting curve. Three-D corner. First element, second element, radius. Okay, I need to change this radius value. Okay, now you can see I'm just creating the corner of this, selecting this corner, first element, second element. You can see the corner has been created here. Okay, you can see the corner has been created with a default radius value. Preview, the corner has been created. We can go with the trim first element and second element. Preview. Okay, for that you need have two curve which is intersecting each other. Okay, then the next one is your then connecting curve. I want to create a connecting curve between this is my first point and this is my second point. I want to create a connecting curve with a tangent with the reverse direction for creating a pure connecting curve. You can see the curve has been created, connect to each other. The next one is your conic. Again for that I need a start point. Let this support as a XY plane, and this is my first start point and this is my end point. This is my start point. Support in this is my support. Go with the conic first point, second point, the first point tangent is this one. Okay, second point tangent is this one, and the support in xy plane point, this one you can see preview. The conic one is created, the conic curve is created with respect to this. Okay, the next one is your spline. So splining is nothing but you can go with creating the spline. Okay, I want to create a spline. There are two types of spline. One is your with the spline of a point, adding point. So I'm just gonna hide some points, point 1, point 2 and point 3. Okay, just creating the spline with the connecting this first point, second point and third point. You can see the spline has been created by using this point, or you can directly add or remove the point from your spline definition preview. Okay, on or else you can go to create a spline by using this plane, first one, second one, third one, fourth, fifth. By using this point we can create the, and here you can give the guide curve, and with respect to this guide the spline is created. Okay, then the next one is your helix. Okay, similarly you have two types of helix. One is your inward or outward. In helix, you can see the helix type, pitch and revolution, height and pitch, height and revolutions. There are three types of helix option is there. One is your constant pitch, another is your variable pitch. Okay, constant pitch means the distance between two curve, this revolution. You can give the distance between the revolution, and the revolution whatever you want you can give one, and one is your inward and outward. Here I'm just selecting the starting point, and I want the pitch size, you can see, let 4, and I want remove revolution 7. Okay, 4. Okay, now, and the axis I want this. Okay, so you can see number of revolution is 4, and the pitch between two it is 4. The distance between two revolution it is 4. Okay, if I will give this 5, you can see the distance between the two revolution it is 6. Okay, now you can see while increase the revolution, it is not following with respect to this profile. Okay, so you can see if I will select this profile, so it will follow the profile, and here you can see it is following the inward. Okay, now the next one is helix in outward. Helix in outward, just selecting this to be outward, select this point, and my axis is this one. I want the pitch, let 20, revolution this. Okay, and here if I will change to outward preview, nothing happened. And if I will increase this one, this angle, the helix is created outward. Inward means it will go with inward. Outward means it will create an outward perimeter with angle 31 degree. Okay, so hope you got the concept of a helix. So helix, you can create the wireframe of a helix in vertical direction. Now here it is that is a spiral. Spiral means the it is one type of a helix, but it will create the wireframe in a parallel plane. I'm just open this spiral. For that you need a support and a plane. So this surface is my support, and this point is my helix start point. Sorry, spiral start point. I'm just creating this. I'm selecting this center point of this. Okay, I'm just selecting the support and this center point where the spiral will be created. Reference direction I want, as you can see, we can give the reference direction in X or Z. We cannot give the reference direction in Y. So reference direction in X, the starting radius I will give here, starting radius is 4, or you can give it to 0. counterclockwise or clockwise movement, um, and angle also you can define. You can give the revolution and end radius like 40 radius. I want to create the spiral of foot 35, and in the angle I want to be 0, and I want the revolution here. You can give the revolution according to your requirement of this here, and you can go with the counterclockwise movement also. Preview. Okay, then the next one is your conquer. So conquer, you can see here in this support you can find 1 2 3 4 lines. Okay, there are 3 lines in the surface. I want to do a conquer or a one curve this over this surface. First line, second line, third line. Extrapolate less distance is 0.3. Preview. Okay, you can see the contour is created over this first line, which is taking the other lines. Okay, so it is basically merge this line of the multiple. It will basically merging the multiple lines in a single line. By using the conquer, we can merge the line with a single line. Then the next one is your isoparametric. Basically this isoparametric is used in your freestyle design, because in there you cannot create the surface is irregular. In there the surface is irregular, that's why we cannot create the parallel curve or any projected curve over the surface. You can see here it is a freestyle design, so we cannot create a curve over this one proper curve. So for that we can go with this isoparametric curve. So you can see we can define this edge corner. So basically this thing is used in your freestyle design. Then we can do the sum operation for creating a particular surface from A surface to B surface. This is all about the wireframe in generative shape design. Okay, then in the next session we will discuss about the surface in generative shape design. Thank you. Jai Jagannath.